So 2019 Part B. We're going to draw the plan first because the question says plan first. So I always do it in the way the question is worded. So plan is mentioned first, followed by elevation. Now, in order to draw the plan, I'm going to project down point A, point B, and I'm going to project down the y-axis also. As far down as I'd like, I'm going to draw a construction line parallel to the line AB. So because AB is horizontal, this construction line is parallel to it. I could bisect this line, and you usually bisect the line to draw the semicircle, but because this is an isosceles triangle, technically this is the bisector, so that's, I should have projected it all the way down to there. Compass on the midpoint, and draw your semicircle. Now, what that gives me is, it gives me a right angle triangle, which shows me the orientation of my plan. So I know that because the y-axis is in the center, that the angle set is 45 degrees. So that's the orientation angle of my plan. The dimensions are 20, 40, and 20. So 20, 40, 20. So immediately, I'm just bringing down construction lines from those points. That's going to help me draw this drawing. Okay. The next thing I know is that it is a hexagon, and that the external angle of a hexagon is 60 degrees. And of course, that 40 millimeter is the length of side. So I can harden in that length of side straight away. And I'm going to choose to draw a 60-degree angle here. So how I'm going to do that is I'm going to set up my set square parallel to the 45-degree angle and just set it out a little bit further. And then this is my 60-degree set square. So if I just go with 60 degrees to that 45-degree angle, I can harden this in fully here. So I harden in that line. And turn it around in this direction to get 60 degrees in the other direction. Of course, you can use your protractor for this as well. And there's 60 degrees there. Now, keeping the set square at the same angle, so 60 degrees here. That gives me that length of side. Flip it back in this direction. So this is why the set square method would be more efficient than using a protractor. And then these lines should line up perfectly at 45 degrees, which thankfully to do again. So that would be down to having sharp pencils and using your equipment accurately. Okay, so there is another hidden detail hexagon on the inside of that. So each length of side should be 40 millimeters. So the quickest, most efficient way of doing this is just mark 20 millimeters across each length of side. Simply getting the midpoint of each side. Okay, and I'm just going to pause the video here, and I'm just going to use hidden detail to draw my internal hexagon. So that's the plan complete. That's what it looks like. Now, moving on to the elevation. I'm going to approach it the same way as I approached the plan. So I'm going to set up the set square in line with the z-axis here. And I'm going to project out point C. Oh, it slipped. So I'm going to project out point C and project out point B. And as well as that, I'm going to extend out my z-axis, and that's going to be beneficial to me. So now, next, I'm going to draw a parallel line parallel to BC. It's just going to take it out as far as I want. So this set square is set up parallel to BC. Just going to draw it out as far as I'd like here. And I'm going to bisect that line. Slightly different from plan. In that plan, we knew the y-axis was in the center between A and B. However, the z-axis is not in the center between C and B here, so I have to bisect it. So there's the center point. draw your semicircle, and again, you're lucky in the past paper and the exam paper that all this construction is given to you, okay? So, and it has been in every single axonometric question so far. So, I always would tell my class that they should learn off how to do this process, because it's the same exact process every single time. And in some exam going forward, they're not going to give you the process. They're not going to show you all of those construction lines. So it is really up to you to learn that off. I would expect that not to be given to us sometime. All right, so as we're looking in from the left here, we know that this hexagon was dimensioned 20, 40, 20. So I'm going to see the same 20 mil section here, 40 mil section here, 20 mil section there. So they're the dimensions I'm going to apply here in the elevation. So 20, 40, 20. The heights we're given the overall height, which is at this point here, and we're told to measure up 20 and down 20. So I'm just going to do that now so as I can take all the points at the same time. So down 20 from the top and up 20 from the bottom. So now, let me see. That allows me to draw a construction line across from there. There. And let's see here. Parallel to this angle. I'm not going to draw this, I'm just going to draw it in the top section and the bottom section. Just that's all where I need it. So here and here. And I'm just going to go one step further there actually and harden those in. Save me setting up the set square at a different time. Just do it all together. So there are immediate points that you can harden in your elevation. Okay, now this elevation looks slightly complex, but you'll see now that it's very doable. Okay, so we have the top and bottom of that done. So now if you look carefully at your elevation, in order to finish it off, it is simply a case that you join that point to there. This point joins to here. So again, I'm just looking at the past papers and drawing like for like. People always look at this question and think that it's very difficult, but it's as simple as this. All right, so there are the lines going down in that rough direction. This point joins to here. And the only line that I've left to draw on that elevation is the line across the center, and all those points should join up parallel to the lines here. All of those lines should be parallel. Okay, and that's part B complete.